the real breakthrough, and you may be familiar with Geoffrey Hinton, who won the Nobel Prize this year. He's often called one of the godfathers of AI. Very well known.
These two know about it.
Yeah,
clearly.
Well, we might talk about him later because he's also a famous sort of doomer at the moment.
Yes.
So that's a very interesting perspective.
Love a bit of doom.
Yeah.
Yeah,
Yes.
but he was at the University of Toronto, and he had a team. So for many years, this neural network approach was also not really going anywhere, and people thought it was probably going to lead to another AI winter. But he worked out that his team worked out if you nested millions and billions of these neural networks together, there was a way that you could start them with essentially zero knowledge of the world, and you could input labeled data. So let's give a simple example. Let's say you wanted to train some sort of AI model to recognize whether a photo is a bird, yes or no. Now, if you think how you would do that in plain English, that's very, very difficult to do. Has it got feathers? Has it got wings? Where's the wing? You might try and come up with some sort of mathematical heuristic about the angle of the beak and stuff like that. It just doesn't want to work. But they worked out a way that you could basically feed in millions and millions of images, some of which are birds, labeled 1. Others are dogs, tractors, cars, labeled 0. And these neural networks could learn from that information using technically it's called backpropagation, which is a mathematical algorithm that basically says if I make one very small change to this small unit of compute, it has these mathematical numbers associated with it called parameters. Do I get closer or further away from recognizing this is a bird? So is my answer slightly better or slightly worse? So essentially what this learning process does is it's doing millions and millions of tiny little tweaks to make this huge computer algorithm slightly better than it was the last time that you went through this loop, just slightly better. And there's a mathematical way you can measure is it slightly better or not. And it turns out that if you do that with big enough computers and big enough data, then the computers can truly learn themselves the structure of this information.
Is this why you need massive data centers?
It is exactly why. Well, you need massive data sets.
Yes.
And you need massive computers.